We have a final exam.
What?
Anybody need old exams? Anybody want me to pass this in my old exams folder? Anybody need old exams? Well, I'll leave it here. If you need it, feel free to grab it. All right, so
Exams from what?
the course. People that never got their first exam or second exam. I know that seems crazy to you, Monique, but some are living a little crazy.
You're putting it all online anyway, though, right?
The scores? Yeah. But I would like to see my test if I was a student. All right, so final exam. When is the thing? Monday? Tuesday.
Calm down.
Shall we move it up? Monique wants to move it up. All in favor? Oh, no. Tuesday, 1 to 3. 1 to 3. Yeah, so we come earlier. That's right. We come earlier to the final, right? Class time's 1:30, but the final, I wonder how many will come at 1:30. Think there'll be a couple?
That's their time.
And what they'll do is they'll beg me for extra time. They'll say, Mr. Heron, because I came late, I should be able to stay late. And I won't see the justification in that reasoning.
I've been reminding myself every day. Don't forget to come at 1.
So 1 o'clock. 1 o'clock on Tuesday, not 1:30. 1 o'clock. 1 o'clock is our final exam. All right, so,
Thursday.
yeah.
So we could just tape our old,
You totally could do that if you want to. Of course, I don't know if you can see both sides that way, but yeah.
That's true.
You can just bring the 3. I'm fine if you want to just bring the 3. That's fine. It's a sheet. You know, feel free to just bring the 3. You don't have to tape or do anything. If you want, you get a full sheet. So if you want to do more room, that's fine too. You get 1 full sheet of notes.
Front and back, correct?
You want the back too? Yeah. No, I'm kidding. Yes, both sides.
And we need to see how big it is, so it can be as big as we want.
Sheet 8.5 by 11 inches. This side.
Don't be bringing in some construction
There it is.
paper that you tore off of the preschool kids' roll.
Yeah, big carried in the big one. All right. If you want help, I'll be in my office Monday 9 to 11, Tuesday 10 to 11. Wednesday won't be much help since your final's over. And Thursday. But there I am. I'm in MSC. You know I'm where I'm down the hall. Room 5.
Oh, boy.
Here in the basement where the
Are you going to
most...
post our final grades on Math Excel? so
Yeah,
we can see?
by Friday. Yeah, they'll be on Math Excel.
That's econ.
Yeah, I know.
Yeah. Yeah, grades. Grades on Math Excel by Friday, 5 p.m. Probably earlier, but for sure by Friday.
That'll reflect our final
Yeah,
grades.
yours will be up earlier, because I think you're getting it early. Yeah, so it'll probably be up Thursday or Wednesday. What's that?
That'll reflect our final grade then. That'll
It'll be percentage. It won't say a letter grade. Right. I can't put letter grade, but it'll say the percentage. Yeah,
Okay.
and it'll be the 90s is the A zone, 80s is the B, 70s is the C, is the syllabus. Yeah,
So it'll be
the
in by
overall
Friday.
percentage.
Yeah, that's weird.
By Friday. You can check earlier, you'll see when the final's entered. That's when it's all in there. Yeah. So,
Lord Jesus.
that's all we've got left, is the final. Should you study for the final?
Yeah.
Huh? What does that mean?
I mean, I know it's silly, huh? It's like, I feel like, say, the answer to that question is if you want to pass the course, basically. If you don't want to take it again, if you want to be successful, like the dentists tell me, they say when asked, should you floss your teeth, only floss the ones you want to keep, right? It's the same kind of thing. Only study for the math finals in the courses you want to pass. I don't know how to put it strong enough. I mean, I was shocked when I first became a teacher and students didn't study for final exams. I was like, really? So there's people doing that? They don't study for the math final? What do they think's gonna happen? But I give a real final, full blown. Everything's on there. I'm a believer in finals because they were so painful and helpful for me. That was my experience. I just teach what helped me. Finals, I hated them, but they were really helpful for me. Just seeing the material a second time really sunk it deep in my mind. I would often struggle along through math classes, in the concepts, I'd kind of get them, kind of not. I'd do my homework and sort of get it, and it'd be confusing. And then studying for the final, having to look at the material a second time, I'd be like, oh, I see, and everything just fit together for me. So I became a big believer in final exams, comprehensive, everything. So it's all there. 26 questions, right? I already told you that. 26 questions. It's all there. We've only had a couple new sections, right? 9-1, 9, was it 2? And what was the other one? 11-3. Yeah. There'll be like maybe 4 questions from those altogether. It's like 22 questions from exams 1, 2, and 3. Yeah, it's mostly the old exams. That's where you want to spend most of your time. Exams 1, 2, and 3, 22 questions. If you don't say that stuff, you're not going to remember it. It's just been a long time. You really need to go back. I always have a couple that are passing the class, don't study for the final, and they fail the course. I just want to be straight up. It's not those who have Monique's responsive nervousness. It's those that are probably not here today, and they're just like, oh, it'll all be fine. It won't necessarily be fine. Yeah, it's funny, I found as a teacher, you're supposed to say positive and encouraging words, and I try to, and I believe in that. But also, I have found students need a little bit more of a warning on the back end. I found there's too much casualness about math. I know everybody says they're afraid of math. I was thinking, if you're afraid, study. Study, right? If you're afraid. Right? I found students think they can pass math classes without doing homework. Students think they can pass math finals without studying. I think, wow, you're a lot more confident about math than me. I was never that confident to try that kind of thing, right? So that's why I'm giving the truth. The truth is some will fail. Some that have registered for this class have a C now and will fail this class because they don't study for the final. So I want to put that in there so that none of you will do that, because I don't want people to do that. It's sad for all of us, All right. Well, with that warning, enough warning. Let's move ahead. I hope that was helpful and will do you good. Why don't we go back over the old exams? That sounded good. You have the practice exams. I thought it might be more helpful to go over the old exams, the actual ones. Because you have the practice exams. Let's do the old ones. Probably all I'm going to have time for is exam 1. I want to do a thorough. I didn't review where we had 3 reasons. Monique and I had 3 reasons in our office why exam 1 is the best. It's the oldest. It's been the longest. It was the worst exam for you guys. It was the lowest score. And I didn't hardly review it the first time. I ran out of time. I only reviewed it for like 20 minutes. Whereas exam 2 and 3. You can find the YouTube reviews of those, right? You know what I mean? Let me show you what I mean real quick to make sure. Here we go. Exam 1. So I'm going to do 1A. If you happen to have 1B, I'll put it online. Oh, in fact, I've only got 1A. I don't even have 1B is the same thing. They're just mixed up order. It's the same thing. So let me just write that. 1B is the same problems. Yeah, different order. So you can find them. So here we go. I'm just going to go through. This is our old exam, 1A. So here we go. Question number 1. Log x equals 1 plus log x minus 1. There we go. So let me write some steps out for you. There'll only going to be 1 log question. On the real final, the final on Tuesday, there'll be 1 log question. There's 1 of everything, basically. So what are the log steps? Well, step number 1, get the logs on the same side. So step number 1, you got to get all the logs on the same side. So grab this log and jump it over here. Log x minus log x minus 1 equals 1. There's the first step. Get the logs on the same side. Step 2, let me write it this way. 2 logs become 1 log. Whoops, not working. 1 log by adding becomes times, subtraction becomes divide. Remember the properties of logs? So 2 logs become 1 log by the properties. Remember that when you have subtraction in the middle, the 2 logs are going to become 1 log. Instead of 2, it's going to become 1 through a special log property. And the subtraction in the middle becomes what? Subtraction becomes division. Like that. becomes a fraction. Now, what if that had been plus in the middle? Yeah, if that had been plus in the middle, I would make it log x times x minus 1, right? If that had been plus. So if it's so adding becomes 1, 2 logs added becomes 1 log multiplied. Right? See how this is only 1 log? Right? We're going from 2 logs to 1 log. And subtraction becomes dividing, adding becomes multiplying. So the way I think, one thing I said that I think was helpful is I called it a log countdown. So in other words, we have 2 logs here, 1 log here, next line no logs. Remember, it's like a log countdown. This is probably an easy way to remember. Put this on your study sheet, full sheet for the final. Put this on your study sheet. 2 logs, 1 log, no log. 2 logs, 1 log, no log. Just kind of easy way to remember the flow, 2 logs, 1 log, no log. So that means on the next line, step 3, I've got to go from 1 log to no log. And when you do that, the base stays the base. The other 2 switch. When you go from 1 log to no log. The base stays the base, the other 2 switch. All right, so I'm going to cross off that log, right? Because I'm going from 1 log to no log. On the next line, there will be no more log. I've counted down the logs. 2 logs, 1 log, no log. Now, what I'm saying is the base stays the base. Now, what's the base? Understood 10. Down below the G, kind of connected to the bottom of the G word the G letter in the word log. Right? Remember, there's always a 10 if there's no other number showing there. Every base has a low down number. Every log has a low down number. Base just means bottom, like bottom of the table, right? Bottom of the logs, down there at the bottom of the G. So put that in there, because I'm supposed to make the base stay the base and the other 2 switch. So the base is going to stay the base. Who's the base? Well, it's the 10. He stays the base. What do I mean he stays the base? Well, he'll continue to have something on him, in other words, right? A base is the bottom of something. There's something on top of it, right? So when I say he stays the base, he's going to stay low with some power on him. What power? Well, the other 2, meaning all that x stuff, that big old x fraction, and the 1 are going to switch positions. Instead of 10 to all that x stuff, it's 10 to the 1. And all that x stuff goes where the 1 was. Remember that special? Right, good question. Good question and clarification on that. Yeah, it's not a sign changer. It's not like, you know how when we jump things, that's a really good question, let me talk about that for a minute. You know when we jump things to the other side of the equal sign, normally the sign changes, right? That's not this. This is a special log maneuver, just because of logs. No signs change. Yeah, the thing you're referring to is what we do all the time, where we're just like equation solving and stuff. You're totally right. When we move stuff to the other side, the sign in the front changes. That's normal equation solving maneuvers, you're right. But this is a special log thing that just happens when you what? Lose a log. When you go from 1 log to no log. Base is base, other 2 switch. All right. Well, having done all that, we now there's no more logs. So now it's a normal equation without logs, which is nice. And it's a little bit of an improvement. Let me get some room here for us to do it. So we can solve it now. There's no logs. So let's solve it from here. Bring it up here. So we have 10 to the 1, which is just 10. I'm not going to write that 1 power anymore. 10 to the 1 is just 10, right? All right, so now we just solve this. We got rid of the logs. We got them out of there. Now we can just solve this. How do we do that, though? What do we do? What's that? Put this over 1, diagonal, crisscross. Yeah, so whenever you have a whole number equaling a fraction, now that'll come up several different times. Whole number equaling a fraction. You got to put it over 1 and go diagonal, cross multiply. So that'll be 10, x minus 1 is 1 times x. Make sense there? distribute. 10x minus 10 is 1x. We're getting close. What do we do now to finish solving this thing? Uh-huh. Good. Subtract the 10x from both sides. This is gone, so we get minus 10, that's what, minus 9x? That good? 1x, take away 10x is minus 9x.
Can you go back up for a second? Please?
Uh-huh.
Sorry. Okay, after you did the first one on top, you did the cross canceling.
Uh-huh.
Okay, and then, okay, so you're gonna write out, so it's, okay, so the x and the 1 cancel out.
So I'm just going, boom, I'm just setting them here.
Okay.
And boom,
Oh,
here.
gotcha. Okay,
We're good?
yes.
Just do the diagonal. And last step is divide by the minus 9. X equals, and the two negatives cancel, don't they? 10/9. If you can see that down there, positive 10/9. Two negatives cancel. And so we solved it. Maybe. It needs to be checked. There is one last thing. Bring it over here. Do the last thing. Logs answers must be checked by plugging into original question to make sure the inside of all logs is not 0, not negative. Kind of make sure it's not 0 and it's not negative. So what was the original question? It was log x minus, no, equals 1 plus log x minus 1. So there's the original question. If I take that 10/9 and I go boom, boom, and this will be 10/9, this will be 10/9. So, we good so far? So what I'm saying is whenever you get a log answer, you got to check them. It's a quick thing. It's not a long thing. You just got to plug in and say, all right, look at this right here. 10/9, x is 10/9 minus 1. Use your calculator. What is 10/9 minus 1? It's positive 0.111111. It'll turn out. It's not negative. It's not 0. Great. Then it's a keeper. Right here, that one also 10/9. Great. It's not negative. It's not 0. So that's our answer. We keep it. If it did make any of the inside of any of the logs 0 or negative, we would throw it away. It'd be no solution. Does that make sense on that? So you cannot, and you can try that in your calculator. Log of a negative number is always error. You can't have the inside of a log be 0 or negative. So if your answer, like what if I had gotten 9/10? If instead of 10/9 I'd gotten 9/10? Well, if you put 9/10 in right here, 9/10 minus 1, that would be negative. And so I would just cross out the answer, no solution. And that's it. Good on that? Questions?
Change a -9 to a positive 10.
Because two negatives?
Make the positive. Yeah.
Make it positive.
Okay.
Good there. All right, let's try number 2. This is exam 1A. 1A. That's all I need to say is 1A. Number 2. So we're going to go e to the minus 0.028x equals 24. Solve for x. 4x there. So something, you know, a lot of the battle on taking a math final is recognition. Something special. You know, every problem kind of has their unique mark. The last one, it was pretty obvious. It was a log. This one, what's like special about this one? It's not really the E. You might think the E. It's not the E. It's the fact that X has climbed into power. That's the thing that needs to jump out at you. You got to say, oh, it's one of them. X is in power. When X is in power, L in both sides. That's what you need to remember. You want to put that on your study sheet for the final. L in, both sides. You got to stick an L in on both sides, not because of the E, but because the X has climbed into the power zone. Makes sense to there? Now, what do you, so that's step number one. Well, L in both sides. Step two, bring the power right down to the front. So that whole E, that whole minus 0.028x, bring that down to the front. Good to there. And ln of E is just 1. You can check it on your calculator. So this ln E part just becomes 1. I'll just cross it off. It's just times 1. We good to there? How do we solve for x? Now divide by minus 0.028. And that gets x alone. Then just use your calculator. And I've got the answer here in my answer key. Minus 113.502. Good with that? Questions on that one? Okay, I'm going to move on. Sam 1A. I'm going to skip to number 4 now. 4 to the x plus 1 is 6. Try that one. So something needs to, it's all about identification. What's the identifying mark on this problem? What's unique? X is like, I'm up in the power zone. So what does that mean we do? L in both sides, right? You always want to look for those marks. X in power zone. So here we go again. L in both sides. Step 2, bring power down to the front. Same kind of thing, right? Getting the hang of that? L in both sides there. It's been so long since we've done this, huh? The weather used to be cold back then. It was like January, February, right? It's the winter months.
That's true.
We're edging into summer here. These are long. I went to Cal Poly. We had 10-week quarters. 10 weeks. Done. This is long, 18-week semesters. These are long. So 4 to the x plus 1. So good there. So L in both sides. And then that power, that x plus 1 drops down. Now, when it drops down, you need parentheses around it. Like that. Why? Because you're saying the whole x plus 1 multiplies the ln 4. Does that make sense? I don't want to just say Mr. Heron says so. If I write it without the parentheses, if I write x plus 1 ln 4, that means only the 1 is multiplying the ln 4. And the x is just outside the deal, not multiplying. Well, why is that so wrong? Because the whole x plus 1 was in the power zone, so the whole x plus 1 needs to become multiplied. And the only way to make the whole x plus 1 multiplied is parentheses. So that's what we do. So now, what does that mean? Now, this ln 4 is going to distribute, right? Whenever you have a number outside the parentheses, and ln 4 is just a big fancy number, which we can find now, or we'll do it later. Whenever you have a number outside parentheses, it distributes, right? It multiplies both of them. So x ln 4 plus 1 ln 4 is ln 6. Good 2 there.
You wouldn't be able to divide the ln 4?
Oh, you could. That's another good option. You could divide the ln 4 and then subtract the 1. Yeah, that's a good idea too. Now, what's 1 times ln 4? Just ln 4. Yeah, so now, what are we trying to do? Here's the wall. X is saying, I want to be, here I am, I want to be alone. Now, whenever you get x alone, it's like peeling an onion. How do you peel an onion? You don't start with the middle. You don't stick your knife right into the middle. You start on the outside, you do the layers. You come on down to the middle, right? So that's what like solving for x is like. This is like it. There's the middle of the onion. So start out here at the outer layer and work your way in, right? So first get rid of that ln 4. 1 times ln 4 is ln 4. Subtract. Right? Why? Because it's added. Whenever we get rid of stuff, we always do the opposite operation, don't we? If something's added, we subtract. If something's subtracted, we add. And if something's multiplied, then last step will be divide. That's always the last step, is divide. So subtract ln 4 from both sides. What do we have now? Bring this part down. X ln 4 is ln 6 minus ln 4. You cannot just make that ln 2. It's not ln 2. It's a little more tricky than that. Okay, last step, we want to get x alone. Do I subtract that ln 4? Divide, because it's times, right? That's x. Whenever something's right next to it, it means times. So that's x times ln 4. So the way to get rid of that ln 4 is to divide. Divide. Boom. There we go. Then you could do that in your calculator. Now careful, when you type that into your calculator, remember you've got to put parentheses around the numerator. Whenever there's more than one item in the top or bottom, numerator or denominator, you got to parenthesize it. Type that in, you should get some number, 0.2925. Make sure you can get that on your calculator. Questions on that one? So if you're having trouble with the calculator, grab me after. I'm going to move along to another problem so we can get as many of these done as we possibly can. So exam 1A, question 5. Log base 15, 24.11. It just says evaluate. Evaluate. When it says evaluate, it wants a value. It wants a number. Do you remember how to do this? This is something we do on our, it's just pure calculator. It's all button pushing on this one. Remember how to do it? 1 log with base number and other number change to 2 logs, higher number, number on top goes, I'm scribbling around here, number on top goes up, base number goes down. So what I mean is, it becomes 2 logs with the number that was on top going on top, and the number lower, the base number, going on the bottom. Like that. And then you just hit the buttons on your calculator. It should get 1.175 from that. So that's how you handle 1 log with 2 numbers. The higher one goes high, the lower one goes low. Make it into 2 logs. So don't miss that one on the final, if it is on the final. That's a freebie, right? Let's just hit the buttons. It's kind of all or nothing. If you don't know what to do, then nothing you can really do. Either know that or you don't. We good to there? All right, so I'm going to move on to, I can squeeze another one in here. Let's go to number 7. Says $36,200 loan. Oh, I see. Oh yeah, no, let's skip that. Let's skip number 7 for now. Let's move on to number 8. That'd be a better one. Yeah, no, 8's totally good. I better go to a new page. So I'm going to go to number 8. So number 8 says, use the formula P equals P0 B to the T. Bacteria. Initial population 10,000. Population declines to 5,000 in 8 hours. What will it be at the end of 10 hours? Okay. All right, so it's been a while, long while since we've done these, and this one's not easy. This is a tough one. So let me go through it with you. And I do remember that this is on the final. This one is. I re-looked over at that final a couple weeks ago to double check it. There's one like this. So, all right. So the initial population is 10,000. Now there's a P, a P0, a B, and a T. Right? Now the P0 is one thing. That's not separate. The P0, that's one thing, right? The B is one thing, the T is one thing. So what is P0? What does it mean whenever they put a little 0 in the lower right-hand corner of something in science? Do you know? Business or science? What does that mean when you got something with a little 0 down there? Initial. Time 0. That's what we mean by initial, right? This 0, the P0 is the 10,000 because it's the initial population. It's the population at time 0. It means P at time 0. That's what the little 0 means. Population at time 0, at the start of the deal. When it just started and there was 0 time on the clock. So that's P0. So first thing I can do is go, okay, they're giving me P0. They're just handing it to me. So I'll just rewrite my equation, but in the place of P0, I'll put 10,000 because they're telling me the initial population, the population at time 0, is 10,000. Good so far? Now they tell me the population declines to 5,000. It goes down to 5,000 in 8 hours. Those bacteria are dying off. In 8 hours, it declines to 5,000. Well, what do I do with that? How am I going to handle that? That means the population is 5,000 when the time is 8 hours. Right? Aren't they giving me a P and a T there? Population 5,000 when time is 8 hours. So these are hard because they're in two phases. Phase 1 is always solve for the B. And then after you finish phase 1 and phase 2, you'll use it. You'll use that value of B to finish the problem. Question?
I just tried something right now and it worked out, I think. I divided 10,000 by 18.
Okay.
5,000 they're asking for is half times 8, right?
Is what? I'm sorry?
If you divide it, 10,000 by 16, it averages out to 625.
Okay.
So you times that by 5, you get the 5,000.
Why is it you're dividing it by 16?
It comes out to 5,000.
Well, you probably have a tricky method here. Let me just do the normal way, but I could be very well right that your way works too. Let's see. So what we want to do now, here's the equation. Got the left side and the right side. There's Roberto, the famous class tutor. What are your hours, Roberto? There's not much left, is there? Tomorrow?
Tomorrow, I guess? Okay.
11 to 2.
Yep.
Roberto's there. All the answers are in his head.
Right.
All right. So we got to solve for the B. The B is saying, get me a loan, solve for B, find B. So what do we do to solve it? Peeling an onion. Who are we going to get rid of first? Right? B is saying here, I want to be alone. Get rid of these guys. I want to be alone. Get rid of these guys. Who do we go first?
10,000.
Get rid of that 10,000. He's multiplied, so we divide him, right? Divide both sides by 10,000. And so what is that? Is that 0.5, and that's B to the 8th? No, yeah, right. 0.5 and B to the 8th. Good there so far? Now that's kind of weird looking. How do we get that 8 off the B? Strange. Yeah, it's not multiplied, but I know what you mean. It's raised to the 1/8 power. You're right. It'll multiply it in the power zone. We call that raising because it's really a power activity. Yeah, you raise both sides to the 1/8 power, and it cancels that out, doesn't it? But you got to do it to the other side also, right? Because whenever we mess with one side of an equal sign, we got to do the same on the other to keep the balance. So where are we at right now? We've got 0.5 to the 1/8 is B. Somebody got a number on that? 0.0625? Just straight?
Yeah.
I mean, that's the whole, is that 0.5 to the, or is that just the 1/8? Maybe I'm confused.
0.5 to the power of 1/8. Looks like I got it wrong.
I got 0.917.
Yeah, I'm getting the 0.917.
0.917?
Yeah, I'll write it down.
Yeah, 0.917.
0.917. I'm going to do a little more accuracy, 004. Remember, whenever you're in the middle of a problem, you want to use a lot of accuracy because you got to use that rounded number to do other things with. So you want some accuracy. So there's B. That's all phase 1. Phase 1 is over. Time for phase 2. What are we going to do in phase 2? Yeah, phase 2, you finish. Now that you have B. So you go back to the same equation again though. The P is 10,000, B to the T. Yeah, but now we know what the B is. The B is 0.917004 to the T. Now that we've found B from part 1, right? And what's the final thing? 10 hours. So that's the time. So you put in the T as your 10. Hit the buttons on the calculator. You should get, let me see, hopefully that'll work out. Well, yeah, I'm right. I've got the answer, 4204.48. Make sure you can get that. Yep, good. 4204.48, want to write that down? If you're having trouble getting that on the calculator, hang out after. Just take 1 minute at most, 30 seconds. I'll be able to help you, or Roberto will be able to help you, either one of us. There'll be double service here. Go either way. Ronald, maybe he has to take off for that. Whatever, at least I'll be here. All right, is that good? Questions on that one? Make sure you can do these things on your calculator. But hang out if you can't. It'll be an easy fix. Calculator stuff's an easy fix. Just hang out for a second. All right. Let's go where? I don't know. It's weird. We're looking at some of these. Some of these are weird. Some of these are normal. How about... Oh yeah, that's good. Okay. Let's go forward to number 11. So I'm still doing... How are we doing on time? Good. Still doing exam 1A. How many total questions are there? All right, we're doing pretty well. I'm looking at, I'm trying to read number 9. Cite this, yeah, it's weird. Okay, I'm gonna go forward to number 11. So, Midtown Delivery Service delivers packages cost $1.90 per package to deliver. So the fixed cost to run the delivery truck, fixed cost to run the truck is $64. Company charges $5.90 per package. How many packages to reach equilibrium? All right. $1.90 a package, fixed cost $64. Company charges $5.90 per package. How many packages reach equilibrium? So give that a try. Give that a try. Give you a second to think about it. You probably get more out of it if I just jump right in. All right, so there's a phrase here that has to jump out at you. Equilibrium. What does equilibrium, you got to know what that means. What does equilibrium mean? Yeah, for a company to reach equilibrium, that means they're breaking even. That's the break-even point, in other words. There's another way you could put it. Break even. Okay, what does that mean? That means cost equals revenue, right? Incoming equals outgoing. Right? They're taking in as much as they're spending, right? The costs to pay for their employees and to pay for their trucks or whatever is exactly equal to what they're taking in. That's the break-even point, the equilibrium point, right? It's a balance point. So that's what they're saying. They want to know, where does cost equal revenue? So that's what you got to make a note on your study sheet for the final. I'm sure there's an equilibrium problem. That was a major thing we did. So when it says equilibrium, you think, okay, cost equals revenue. All right, so let's get a cost equation, and then let's get a revenue equation, and we'll set them equal and solve. That's the plan. So what's my cost equation? What costs are there? Yeah, go ahead. What costs are there?
1.9x plus 64.
Correct. Does everybody see that's 1.90 or 9x plus 64? So everybody, why does the 1.9 get the x and the 64 doesn't? That's correct. Why is that?
You don't know how many packages? Fixed cost.
X number of-
It's because 64 is a fixed cost, meaning it doesn't depend on how many packages. It just takes, they're renting the trucks for $64 a day or whatever, right? It doesn't matter how many packages. It costs $64 for the truck. But the packages cost $1.90 per package to deliver. I don't know, they're paying postage or whatever. It's $1.90 per package. So that varies. That gets the variable. So everybody see that? Whenever something varies, it gets the variable. Right? Because that's good. How much did you guys spend on per pack? How much did you spend on delivering the packages? Well, it depends how many packages. It's $1.90 for every package. So if we did 100 packages, you'd multiply that by 100. If we did 73 packages, you'd multiply that by 300. It would depend. Well, how much did the truck cost? $64. Period. Well, what if you did 100 packages? $64. What if you did 10,000 packages? $64. Right? That's fixed. It doesn't have a variable with it. Does that make sense? So there's the variable thing that depends on your however many packages. X is how many packages, right? You can call it P if it is helpful for you. Yeah, want to make it P? P for packages, right? However many packages times $1.90 per package plus $64. That's all the cost the company's putting out, right? They have to spend $1.90 per package times however many packages plus $64 to rent the truck. Now, what are they going to take in? What's their revenue? What's the money coming in? Yeah, 590 times P. It's number of packages times 590. They're going to collect 590 for each package. They're offering a service. They're going to collect 590 for each package. Is that good? And then we set those two things equal. You take 1.90p plus 64 equal to 5.90p. Because you want cost to equal revenue at the break-even point, at the equilibrium point. So that's the equation I'm going to solve. So now, let me bring it over here. 1.90p plus 64 is 5.90p. How do I solve that for P? Yeah, the wall is here. Whenever, notice how we have the P on both sides. Whenever you have the letter, that's a little different than the last couple equations we solved. Whenever you have the letter that you want to solve for, when the letter's on both sides, you get rid of the lower one, huh? Or either one, doesn't matter. Just get rid of somebody. So yeah, I'll do exactly what Josh is saying. Subtract 1.90p from both sides. That makes sense there. And this is 4p. Right. Divide by 4, and the answer will be 16. 16 packages. So what that company would think, that'd be an important calculation for that company, that small little company. If they can sell 16 packages, they can break even. So anything more than 16 packages, they'll be making profit. Anything less than 16 packages, they'll be losing money. That's their break-even point. Some companies definitely calculate. Is that good on that? So equilibrium point, revenue equals cost. Income equals outgoing. Okay, shall we move forward? Let's try. I'm looking at number 13. And I'm on exam 1A. Number 13 talks about biologists recorded 8 snakes on 18 acres of land in a certain area, 11 snakes on 25 acres. Y is snakes, X is acres, and find equation. Linear. Find a linear equation. So it's been a long while, and this is weird since we've done ones like this. Find a linear equation. So when they say find a linear equation, they mean find y equals mx plus b. Does that make sense? That's the linear equation. So these words need to jump out at you. Linear equation. That's the unique mark of this kind of a question. Linear equation. Y equals mx plus b. Now how am I going to do that? Well, they're telling me that y is snakes. So this is y, this is x, this is y, and this is x. So in other words, I've got the point here. I've got 1.188. See how I switched them? The 18's the x, got to come first. And then the 2511, right? X has to come first when you make points, right? X has to come first. So, all right, so how do I go about this? Well, it's not easy. Step one. So step one is you've got to have a slope calculation. Remember slope? Remember the formula for slope? y2 minus y1 over x2 minus x1? Remember that old slope formula from your algebra days, your glorious algebra days? Those best days of your life? No, maybe not. So, that's what we got to do. So now what do we mean x1? This is x1, y1, x2, y2. So y2 minus y1, 11 minus 8, over x2 minus x1, 25 minus 18, what's that, 3/7? The slope is 3/7. Good so far? So that's step one. Find the slope, 3/7. Step two, let's use the M formula one more time. But I'm going to change it slightly. So this is my own little thing. This isn't what Math Excel said to do. This is something I learned years ago. A student actually suggested. They'd heard it from another teacher. That's where I usually get most of my best ideas, things that have really worked well for students in the past. They tell me about them, and I'm like, oh, yeah, that is cleaner. So what I'm going to do is I'm going to use this little slope formula, and I'm just going to erase the back. Remember, it's like you use the slope, and you get rid of the little 2's. So it becomes like a simpler version. Just y minus, just leave a blank in the back, and x minus, leave a blank in the back. This will be easier. So this is phase two. Grab that slope we just got and plug that in for m, because now we know m is 3/7. Okay, and now what am I going to put in the back of y and the back of x? Well, a y value in the back of y and an x value in the back of x, right? Like you could put y is 8 in the back of y and x is 18 in the back of x. Or you could do that other pair. It doesn't matter. Just stick one pair of the numbers, but don't mess them up. Make sure the y goes behind y and the x goes behind x. Good so far. And then go diagonal, diagonal. So 3x minus 18, 7. Well, remember that crisscross, diagonal multiply thing? We're almost there. This is a long one. And then so distribute 3x minus the 30 times 54. 7y minus 56. Like that. Solve for y. Y is saying, I want to be alone. Remember, you're supposed to get y alone in the end? Y equals mx plus b. Y alone, right? So let's get y alone. How do we get y alone? Good. Peel the onion around the y, right? Y is saying, I want to be alone. Peel the onion around the y. Get rid of things next to y, starting with the outer layer. Got rid of the 56. 3x, what's that, plus 2. Last step, divide by 7, divide by 7. There it is. Y is alone. 3x plus 2 all over 7. That's the relationship between snakes and acres.
You always want to get y alone.
Yeah, always y alone. Is that good there? That'll take some practice. Questions I can answer?
Are you going to care on the final if it's in decimals or fractions?
I won't care. Either decimals are fine, or fractions. Yep. Good, all right. 14 from exam 1A, skip it. It's about using our calculator to do something called linear regression. I don't know if you remember that at all, but it's one thing. So I'm not putting weird things we did only once. I'm doing like main things that we did a lot of. So that won't be on there. Let's see what else we got. Okay. We could jump forward to like number 16. The electrician charges $45 plus $30 per hour to do whatever. Let C of X be the charge for X hours. All right, so can you write a formula there? And they just want a formula. C of X equals, they just want a formula for C of X. Can you write a formula for C of X?
Would be 30x 45.
Right, exactly. 30x plus 45, because the 30 again is the variable, huh? The 45 is fixed. It's just 45 straight. Well, that went quicker than I thought. That's all you need from exam 1. We could do some of exam 2. Those are so I skipped around, but those are the ones that are going to be in the final. Those are the ones. The other stuff I skipped is small little silly things here and there. Those are the main meat and potatoes from exam number 1. Let's see, let's do a little bit. We got 15 minutes, or a little over 10 minutes. So, let's see. Yeah, so, I'm going to put all formulas, did I give you, at the top, all formulas at the top of exams 1 and 2. There were none on 3, were there? No, none on 3. Exams 1, whoop, it was a funny looking 1. Exams 1 and 2 will be on top of the final, looking exactly the same. So those exact formulas will be up there. They'll look exactly the same. It's already up there. So what that means is we just got to remember how to use them. Yeah, it might be good to do just a tad bit of a review. What would be the best? We've only got 10 minutes. What would be our best use of time? There's going to certainly be some of these. Find the amount. Okay. All right. I'll just do one of these. I'll do number 1. So exam 2A now. Question 1. Blah, blah, blah. Okay. Borrow 10,000 to purchase a car at 15% annual rate, 15%. She has to pay back monthly payments end of each month over 5 years. Yes. Sound familiar? Borrow $10,000, purchase a car, make the payments back over 5 years. My daughter just did this. She bought her first car last week with me co-signing. Yeah. But anyway, so, and she didn't get 50. I would never have gone for a 15%.
She got a 15%?
No, that would have been terrible. That's horrible. I think it was 3 1/3 or something. Anyway, not 15. That's just murder. You're just giving away your money. Anyway, I'm big on not paying interest when I can avoid it. Although I've paid a lot of my house payments. Anyway, enough with my financial woes. Let's solve this problem. Now, remember we had some formulas, and when you see, there's a couple of words need to jump off the page for you there. Because you got all those formulas. If you have exam 2 there at the top, I'll write the one we need in a minute. But you have a whole bunch of formulas up there at the top, and they say things like future value ordinary annuity, future value annuity due, present value ordinary annuity. Let me just write the names down. How about? So the names are future value ordinary annuity. There's that one. Then there's not present, future. Come on. Future value annuity due, and then there's present value ordinary annuity, and then there's compound interest. There's 4 formulas in this from this exam. There's 2 from exam 1, 2 simpler ones. So there's those 4 big honking formulas at the top. They'll be up there in the final in the same exact way. So how do you know which of those 4 is? Well, what are some words that jump off the page for you? Yeah, end of the month. What does end mean?
Future value ordinary annuity.
How do you know it's future? Let's back up. You're right about the ordinary.
I just that.
Let's key on the word payments first off. What does payments mean? It's an annuity. So it's not the compound. Bye-bye compound. It ain't you. Right? Payments mean annuity. You with me on that first off? So whenever you see the payments, like making house payments, car payments, payments to a retirement account, that's paying yourself for the future, right? So all the payments, regular same amount every month kind of thing, or every year, or every whatever, regular payments, annuity. Those are annuities. Now, second, how do we know if it's a future annuity or a present annuity? And then we'll get to the other thing.
It's money that she already received, so it's coming off the phone.
Yeah, where's the pile? That's the question. Where's the pile of money? Has the money already been given?
Yes.
Or what the money buys? Yeah, you got the car, right? My daughter's driving the car. That means the bank has done something. Michael Toyota didn't just hand her that car because they're nice, right? The bank sent a check to Michael Toyota, right? So that's what happened. Pile has been handed, right? So pile is at the start. So remember, it's all about, so remember we had the big pile at the start and then coming off, or pile at the end. So pile at the start. So that is present value. That's present value of an ordinary annuity. You see how we know it's present value? Because the pile is here. It's not in the future. If you're storing for retirement, then you're building up a pile in the future. But if you're paying for a house or paying for a car or anything you buy now, the pile has been given by the bank to the house buyer or to the house maker or to the house car maker, right? So the pile is now. If you have the thing now, you have been handed the pile now, and you're just paying it back, right? So whereas retirement is future. So this is present value, present pile. Ordinary, yeah, what's the ordinary? Honestly, I'm not going to give you annuity due. That was a weird one. See, anything weird that we only did a little bit of, cross it off. There's no annuity due in the final. That was like beginning of the month. That was weird. We didn't normally do it that way, right? They're going to be ordinary annuities. It's just present or future, present or future. So I'll just leave it at that. You got to, let me do it. I think it'd be better if I did another setup one, right? We have 5 more minutes. So then you just use that formula, which is not easy, but practice that with your calculator, plug all that stuff in, crank that out. Let's try another one. Make sure we can tell whether it's future, present, or past, or whatever it is. How about number 5? Is that another good one? We could do number 5. All right. Find amount in bank. Put in bank now at 8% compounded quarterly. That's n equals 4, huh? 4 times a year. To allow what? $650 withdrawals at the end of each quarter for 6 years. Okay, so try that one. And all I mean is identification. Let's just play the identification. Let's do one more. This one and one more identification game. Is that, so is it annuity first off? Or is it just the we have 3 annuity formulas and then the compound interest formula. Is it an annuity? Are there regular amounts of money coming somewhere? Are there regular payments? Yeah, $650 withdrawals. That's regular. I'll take $650. I'll take $650. I'll take $650, right? So yeah, it's an annuity. It's not just a compound interest question. Everybody see that? It's an annuity. Okay, find out where the pile is. Give yourself a second to think about it. Is the pile now or is the pile later?
Future.
Where's the pile? Where's the pile of money? What's this word say?
You already put it in the bank now.
Pile now. Right? I'm finding out. I got to go to the bank, and I got to put a big chunk in the bank. Right? Maybe my daughter's gonna go away to college. It's the same daughter. She cost me a lot of money. I like that daughter, but she's an expensive girl. So I'm gonna go to the bank, put a chunk in the bank, so she can go away to college and pull off every month for living or something. Right? That's the kind of thing they're talking about. Right? You want to put a chunk in the bank so that $650 can be pulled off every month. Right? So the pile's now. Pile now. It's another pile now. So it's present value of an annuity. Now, this one's one that I told you will not be on the final because it's end, so that's actually annuity due. I'm not going to put that in the final. I give you an ordinary. But I just wanted to test you again on the present value, future value. Where's the pile? Is that making sense? Is that good? Let's try one more. We'll do one more setup if you got that one. Number 7. Let's squeeze number 7 in down here. Payments. There's the word payments. We know it's in another annuity, huh? $2,500. End of each quarter at 4.3%. Compounded, whatever, blah, 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 for 16 years. How much accumulated at the end of 16 years. So ask yourself about the pile. Oh, that last one, number 5, was ordinary, wasn't it? I got confused. That wasn't normal. That was ordinary. So it was one I could put on the final. Yeah, it was ordinary. Because it was at the end of each quarter.
Present value ordinary.
Yeah, it was present value ordinary annuity. Yeah, I was thinking it was something weird. It was, yeah, present value ordinary. It was in. Yeah. Anyway, number 7. Where's the pile on number 7? Where's the pile of money? Just be real life with this question. What are we doing? We're putting $2,500 into the bank each quarter. How much accumulated? What kind of pile at the end? Right? This means pile at the end, doesn't it? You want to build, it's like saving for retirement or for a family vacation or your kids going to college or something, right? It's storing up a pile for the end. So it's a future value. This one here. This one's future value of an ordinary annuity. You would use that formula. Does that make sense? Pile at the end. All right. Well, those are some of the different annuity ones. We've done a lot of math in 17 weeks, and next week we'll take the final to wrap up our 18th week. All right.